No graph is neutral. No one presents a graph without trying to influence you in some way. The graph represents what the author thinks is true, or wants you to think is true. The author may think their graph is accurate and without bias. Why then are they showing it to you? No one ever said, "Hey guys, let's draw a graph, it'll be fun." The three most common graph types are pie chart, bar chart, and line graph. Everyone has seen many versions of each, even if they didn't notice the type at the time. A pie chart is a circle with slices representing categories. The sizes of the slices correspond to the proportion of the whole the category represents. There is no natural ordering of the categories, and slice colors are arbitrary. The category name and amount are usually shown on the slices. This pie chart supposedly shows who gets what percent of the price of a gallon of gasoline. From this pie chart, it is clear that the refinery margin is the largest and state sales tax is the smallest. A pie chart can be rotated to emphasize a category. The category at the front looks larger than it actually is. This is not a misrepresentation of data. It's a visual trick. Look here, not there. The chart still shows the category names and percentages. You just have to find them. This is a way to take advantage of your perception of the chart. As the great statistical philosopher Obi-Wan Kenobi said, "So what I told you was true, from a particular point of view." Or we can change the colors and stretch out the x-axis. Another way is to remove the percentages from the chart, leaving only the labels. Now the small categories loom large, with no values to confuse the issue. Another way is to rotate and explode the chart. The dealer's margin now looks like the single largest portion of the cost of a gasoline. Now you ask, why would anyone do such strange things to an innocent pie chart? If you look at magazines, newspapers, or television ads, you will find examples of your own. I have a few favorites. Here is Steve Jobs showing how large the iPhone market is as a percent of the whole. Looking at his pie chart, the 19.5% iPhone share stands out. The chart is tilted backward slightly to make the lower portion stand out, and the iPhone slice is separated and pulled forward. The vivid green color makes it stand out. The iPhone slice is clearly smaller than the blue slice at 39%, but the color difference makes the larger slice fade into the background. Also, the 21.2% category in the upper left is larger than the iPhone's 19.5%, but it sure doesn't look like it. Mr. Jobs isn't the only pie chart manipulator. There are dozens of other examples from many different sources. This pie chart is from an education publication. It shows something, but I don't know what it is. This well-known chart from the 2012 presidential election is even better. The percentages add to 213% and have no relation to the slice sizes. Anytime you see a pie chart tilted, exploded, or oddly colored, someone is trying to hide an inconvenient truth. Bar charts have horizontal or vertical bars comparing amounts by category. Most bar charts have no natural order, with notable exceptions being Pareto charts and histograms. The most common trick is to begin the bars at a y-axis value that exaggerates differences in bar height. The chart on the left shows a clear preference for hot dogs as snack food compared to pizza and hamburgers. The y-axis begins at 930. The chart on the right shows the same data with the y-axis beginning at 0. Hot dogs are still in the lead, but the difference is very small. This chart purports to show the effect of a tax rate change. The large height difference in the left-hand chart comes from the y-axis beginning at 34%. The right-hand chart shows the actual difference, 35% and 39.4%, more accurately. Another common trick is to use 2 or 3-dimensional bars that imply large differences between categories, or simply obscure some information. Line graphs often show a progression through time. They are easy to manipulate because both the x and y axes can be distorted. This chart shows the growth in COVID cases from February 21, 2020 to March 24, 2020. The x-axis has equal width between marks, but the number of days between marks is not the same. The actual curve is much flatter at the beginning and steeper toward the end. This graph has unequal intervals on the y-axis. The intervals are mostly 30 units wide, with 10s and 50s at places where a pattern is squashed or emphasized. This chart from a newspaper purports to show the decline in revenue for Freight Car America and the number of manufacturing jobs in Roanoke, Virginia. The presentation makes it appear that the declines in revenue and jobs are related, or at least following the same path. First, the y-axis in the upper revenue graph is in millions of dollars. The y-axis in the lower jobs graph is in manufacturing jobs in thousands. These two axes have absolutely nothing in common. No amount of adjustment can put them on the same basis. Also, the y-axis of the jobs graph begins at 14,000, not 0, as does the revenue graph. Second, the x-axis in the upper revenue graph extends from 2006 to 2010. The jobs graph begins at 1900s. It's unclear as to what 1900s refers to, but by counting marks on the graph, it appears to begin in 1989 and extend to 2010. Ignoring the incompatible y-axes, starting the jobs graph at 0, and making the time periods correspond, the graph looks like this. Even the most unbiased graph producer presents what they believe to be the truth, but the graph is still based on their experience and opinions. However, graphs with distortions are usually deliberately altered to show or hide some feature. Always consider the source, what point the graph is trying to make, and why someone has special knowledge of the subject that allows them to produce the graph.